Okay, in this video, we are going to be looking at solving radical equations. Sort of my favorite part of each section is solving equations. So we'll have radicals, there will be an equal sign and some other stuff, and there will be an x in there somewhere. And at the end, we'll want x is equal to a number. So before maybe we get started solving those, we need to pull up a principle. And you might have seen this one before, but it's called the principle of squaring. And what it says is that if you have an equation, that one something is equal to something, that if you square that first thing, as long as you square the other side, you're okay. That the equation remains true. And we've done lots of that, right? 2x equals 4. So if you divide this side by 2, you divide that by side by 2. If I have x plus 2 equals 4, if I subtract 2 on this side, as long as I subtract 2 on that side. So principle of squaring is the same thing. The nice thing with that this one allows us to do though, like say for example, if I have the square root of x is equal to 4, I want x by itself, x equals something. So I have to get rid of the square root. So the way that you get rid of the square root is by squaring. So if I square that side, I square this side. So the square root and the square, those cancel each other out. I don't know if the book shows you to do it like that, but that's how I do it. Anyway, and so I'll get an x, and then on this side, I just figure out what 4 times 4 is. 4 squared is 16. Here's a couple of steps, and the book shows some too. Their steps are very similar, that you can use to solve. The first thing you want to do when you are solving an equation in which there's a radical is you have to isolate the radical. In other words, you can't have anything adding, subtracting, multiplying, or dividing to that radical. For example, here's my radical right there. It stops right there. And I'm subtracting something from it. I got to get rid of that. So I have to do something to get rid of that. Once I've isolated the radical, then I'll use the principle of squaring, square both sides. Then, if I still have a radical, I have to isolate the radical again, do the same thing up here. And then lastly, once I've got rid of all radicals, then I solve the equation just like I do any other equation and come up with my answer, x equals something. And we'll say this again in another slide, but always make sure you check your answer at the end. With square roots, there's some squirrely things that happen, and you have to make sure you check your answer to make sure you're correct. Let's just try it with a couple of questions. So here's my question. I need to isolate the radical, so I'm going to add 5 on both sides. If I add 5 on both sides, then on the left side, all I'm left with is the square root of 3x equals 3 plus 5 is 8. Now I'm going to use the principle of squaring. You could just square right here. I like to write it in another step, just so I can see what I do for each step. So this one, I'm going to square this side. That'll cancel those two. And I'm going to square this side. So I'll be left with 3x is equal to 8 squared is 64. Now I've got a normal equation. I want to solve for x, so I'm going to divide both sides now by 3. Again, I'll write out another step. It just helps me when I'm going back to check my work. So I'll divide this side by 3 and divide this side by 3. The 3's are a factor of 1, they cancel. So x is equal to 64 divided by 3. Okay, so I've solved, I better check my answer. Let's go back. Root of 3x minus 5 equals 3. So here's my check over here. The square root of 3x minus 5 is equal to 3. So I'm saying the answer is 64 over 3. So the square root of 3 times 64 over 3 minus 5 is equal to 3. Checking to see if that's right. Well, these 3's cancel here. So really I just have the square root of 64 here. Take away 5 equals 3. Square root of 64 is 8. 8 take away 5, yeah, that's 3. Therefore, my answer is correct. Let's try a couple questions. I'm going to just maybe go through a bunch of them just to make sure that you're comfortable with them. Here my radical is on the side of the equal sign by itself. It's already isolated. So I'll take y plus 4 is equal to 12, and I'm going to take this side and square it, and this side and square it. On the left side, left with y plus 4. On the right side, 12 squared is 144. Subtract 4 from both sides, and I get y is equal to 140. Let's check. Just to make sure that we're good, square root of y plus 4. So the square root of y was 140 plus 4. Is that equal to 12? 140 plus 4 is 144. If you take the square root of 140 on your calculator, 144 gives you 12. That means that this answer is correct. Let's try this one over here. Here's my square root. There's my equal sign. So this 4 is bothering me. So subtract 4 on this side, subtract 4 on that side. So I'll come up with the square root of y minus 3 is equal to 11 take away 4, 7. I've isolated my radical. Now I'll square both sides. So y minus 3 equals 7. Now I'll square this side and square this side. So the square and the square root cancel, leaving me with y minus 3 is equal to 49. I'll add 3 to both sides, so I get y is equal to 52. Let's do our check. And again, with your check, you always have to go back to the original equation. So 4 plus the square root of y minus 3 is equal to 11. Is equal to 11, that's my equation. So now I'll plug in my 52. So 4 plus the square root of 52 minus 3 is equal to 11. 52 minus 3, that's 49. So 4 plus the square root of 49, is that equal to 11? Square root of 49 is 7. 4 plus 7 is equal to 11. Yes. Therefore, 52 is my correct answer. Okay. Ooh, here's one with 2 square roots. This one looks fun. They're both isolated, so they're both on a side by itself. There's a 3 here, I guess, with this one, but maybe it'll work out. Since it's being multiplied, I think we'll be okay. Again, we'll have to check it. Here's that slide I was telling you about. You need to check. Okay, I'm going to square this side and square this side. Okay, if I'm squaring, this is the power of a product rule, where I have to square the 3, that's 9, and I have to square this thing. Well, when I square this thing, it cancels it out, right? So I'm just left with x plus 1. Notice I put it in brackets there, because this is multiplying. It's multiplying by anything that's over here. Is equal to the square root cancels, so this would just be x plus 12. Okay, let's use distributive property. Equals x plus 12. Now let's take and bring the x over here and subtract it. That'll be 8x. And let's take the 9 over there and subtract it. So that would be 3. 12 take away 9, yeah, that's 3. Now, divide both sides by 8. So this will be x is equal to 3 over 8. Now, in checking this one might be a little bit nasty to check. I might have to use the calculator on this one. So it'll be 3 times the square root of 3/8 plus 1. And is that equal to the square root of 3/8 plus 12? Okay, so let's bring out a calculator. I don't know if, this might work. Oh, I can't see anything. So square root of, what was it? Oh, come on, go away. 3/8 plus 1. Okay. Square root, let's get rid of this stuff. Square root of 3/8 plus 1. Computing. Come on. You can give me the answer. Okay, good. Decimal is 1.17. And now let's times this by, there was a 3 out front, right? Okay, so I'm getting 3.5 about. Now on the other side, I have 3/8 plus 12, so that's 12 and 3/8. So let's go back to our calculator. Square root of 3/8 plus 12 it was, right? And my answer was 3.5. Okay. 3.51. Same answer. Therefore, this side is equal to this side. Therefore, the 3/8 is my correct answer. That's a tougher one to determine with a calculator. Here's another one. We haven't had one that doesn't check yet. Let's just see what happens here. So I'll square both sides and I'll get 3x plus 1 equals 2x plus 3. Bring this over and that'll be an x. Bring that over, it'll be a 2. Let's just check to see if it's correct. Put a 2 there. So 3 times 2 is 6 plus 1 is root 7 on that side. 2 here, 2 times 2 is 4 plus 3, and it's root 7 on that side when I check. So that one is correct. Darn, I'm hoping to get one that doesn't work. Oh, this one looks interesting. Maybe this one won't work. We'll try it. Okay, isolate the radical. Done. It's on the side by itself. Squaring. Okay, let's square this. Oh, that's a binomial square, so I have to write it out like this. This one can't be, I might just write it over here, x minus 1 squared is not equal to x squared plus 1. No, stop, don't do that. Okay, so I'm going to have to FOIL that out. Is equal to, square of that is x plus 5. Okay, so FOIL it out. X squared minus x minus another x is minus 2x. Minus 1 times minus 1 is a positive 1. Is equal to x plus 5. Oh, no. Different kind of an equation this time. All the ones we've done so far have just been x's. So I bring x's to one side, numbers to the other side. But this one is a quadratic because there's an x squared in it. So I have to bring everything over to the left side. So it'll be x squared. Okay, subtract an x, subtract, that'll be a minus 3x. 1, and then here I have to subtract 5. So 1 take away 5 is a negative 4. Is equal to 0. Okay, now I can factor that. Oh, remember that factoring? Everybody's favorite section. An x and an x. Okay, 4 and 1 I'm thinking. So probably a minus 4 and a plus 1. X squared plus x minus 4x. Yeah, that's right. Minus 4 times 1. Yeah, that's right. So now in solving this, I use a 0 property. So x, this factor has to equal 0, or x plus 1 has to equal 0. So here x is 4, or in this case x is equal to negative 1. Interesting here, I've got 2 answers for this question. Let's go back and check them. I'm just going to grab the question here, just so I don't have to type it again. Let me go down a bit. All right, so let's check. Well, maybe I'll do 2 of them, eh? Put that one over there. Okay, so I'm going to put a 4 in. 4 take away 1 is equal to root 4 plus 5. 4 take away 1 is 3. 4 plus 5 is 9. Square root of 9 is 3. Yeah, that one checks out. This one's good. Okay, negative 1. So here I have negative 1 minus 1 is a negative 2 equals square root of negative 1 plus 5. Negative 1 plus 5 is 4. Square root of 4 is 2. Uh-oh. This side's a negative 2. Those aren't the same. Therefore, this answer doesn't check. So it's not an answer. I wouldn't include it in my answers. Only that one is the correct answer. Okay, yes, finally found one that doesn't check. Yeah. All right, here's some other ones. You can try these. I might just, I might skip over those because to solve these would be the same thing. Like that one, you'll square both sides. Square both sides and you get x plus 7 equals, on this side you'll have to FOIL. So I think it'll be that. Then you bring the x over, bring the 7 over. So you have 0 is equal to x squared minus 11x, and then plus 18, I think. And then factor, etc., and check. Okay, this one, I'd have to take the 1 over to this side because I have to isolate that radical, right? So the root of 1 minus x is equal to x take away 1. Square both sides, so I'll have 1 minus x is equal to x minus 1 times x minus 1. x squared minus 2x plus 1. When you FOIL all that out, this is what you get, equals 1 minus x. And then bring the minus x over, become a positive x, so this will be a minus x. I'll have an x squared. And when I bring the 1 over, it becomes a minus 1, and 1 take away 1 is 0. Oh, so there's nothing there. Oh, so I don't have another term there. So on this one, to factor it, I can just look for a common factor. I can take an x out. This would leave me with an x, take away 1, equals 0. Again, 0 property, so x equals 0, or x minus 1 equals 0. In this case, x is equal to 1. So I have two possible answers. I'd want to take them back into my original equation, not this equation here, but the original one, and check to see if they're right. Let's check 0. I put a 0 there. 1 take away 0 is 0. Square root of 1 is 1. 1 plus 1 is 2, not 0. So this one doesn't check. Nope. No check. How about positive 1? I put a positive 1 in there and there. Okay. 1 take away 1 is 0. Square root of 0 is 0. 1 plus 0 is 0. I get 0 on this side. No. 1 plus 0 is 1. Sorry, 1. I get 1 on this side. And I have 1 on that side. Therefore, this one is correct, not that one. Okay, here's one where we do the principle twice. And I think I'm going to, well, maybe show you how to do it. But in Math 75, we typically don't do these a whole lot. I wait typically for Math 85 to do these ones. But I'll show you how to do it. Anyway, I have this radical isolated. This one's not isolated. But this one is, so I'm going to take and square this side, because that'll get rid of this one. But then when I square this side, you'll see some ugliness start happening. So I'm going to have root of x minus 1 times the root of x minus 1 is equal to x minus 3. Okay, when I FOIL, root of x times root of x is just x. Root of x times minus 1 is a minus root x. And then another minus root x. And a plus 1 equals x minus 3. So this will be x minus 2 root x plus 1 equals x minus 3. Now, let's gather x's maybe and numbers. So if I subtract x on both sides, oh, those cancel. So on this side, I just have minus 2 root x. And then I'm going to take this 1 over to the other side and subtract it is equal to negative 4. Just take a look at that a sec. Make sure you're okay with that. The x's, it comes over here as minus x cancels. So I just have this. And then I take the 1 to the other side and subtract negative 4. Divide both sides by negative 2, and I get root of x is equal to positive 2. Still have that radical, so now I need to square both sides again to get rid of it. So I'll square this side, and I'll come up with x is equal to 4. So there is my answer. Now let's check and see if it's right. So I'm putting a 4 in everywhere I see an x. Okay, square root of 4 is 2. 2 take away 1 is 1. So 1 is the answer on this side. This side, 4 take away 3 is 1. And the square root of 1 is 1, so I get 1 on that side. Therefore, this answer is correct. Okay. Last question that I'll do, I guess there's a couple questions, but is one that involves a formula that has a square root in it. So the how far the horizon can you see through an airplane window? So the distance you can see depends on height, how high you are up. And this one is in feet. The formula is in feet. Okay, so if they say you're 38,000 feet up, distance equal to square root of 2 times the height of 38,000. Okay, so 38,000 times 2 is 76,000. So now on my calculator, I just have to do the square root of 76,000, which is 76,000. I should have brought a different calculator. 275.7. Oh, exit out of that. 275. What was it? 275.7. I don't know if that's what the calculator said. Anyway, you get the idea of how to do that one. Here's another one though. In this one, they say how high up do you have to go in order to see this far out. So I put my distance here, so it'd be 10.2 miles is equal to the square root of 2 times h. And I want to know what h is. It has a square root, so I'll square both sides. So I'll get 10.2 squared. I don't know what that is. 10.2 squared. 10.2 squared. 100 and something. 104.4. Okay, 104.4 is equal to square this side, I just get 2h. Divide both sides by 2, and I'll get 52.2. So that's how many feet you have to climb up in order to see out that far. Okay, so in this section we've looked at solving radical equations. We've looked and seen that you need to isolate the radical, use the principle of squaring, and then use your rules to solve. And we've seen that checking your answer is an important thing too. Try some questions.